Hey everyone, it's me RGB guy and this is the second video of my introduction to Unreal Engine series. If you haven't checked out the first video, here is the link to it. In this video, we'll be covering all these topics, so without any delay, let's get started. So this is where we left off last time. We added a few objects, we also added a few lights and particles. We changed the directional light a bit and then we added this landscape and we also colored this landscape using materials. If you look at the right side of your engine, you'll see a settings menu. If you click on the settings menu, there would be world setting, project settings and plugin. So let's go to world settings first. When you click on world settings, this tab will open up. So world settings are all the properties or all the settings that are related to this particular level. Each level may require some different kind of world settings, and that is why this is here. So inside world settings, you can define various properties about this world or this level. Let's just hover over a few settings and just try to understand what they are. Inside world settings, you can define game mode. A game mode is a class that defines all the rules for your game. How many players can join in? When will the game end? For example, in Call of Duty, you'll have different game modes like capture the flag, free for all, or a team deathmatch, right? So that is a game mode. So game mode defines all the rules for the game. For this level, what is the game mode that you can set here? Inside that game mode, you can set different settings. What is the pawn? What is the player that we are playing, right? What is the HUD class? What is the player controller class? We'll go over all these classes in detail later, but let's just understand what world settings is. Similarly, what is the kill Z? Any actor falling below this level gets destroyed. We do not want all the actors to stay in the level, right? Let's say an object falls down in a level. How below should it go? We have set the kill Z to -1000. What this means is any actor that falls below a -1000 Z value will get destroyed. You can set all those settings here. Override world gravity. Enable this. Right now your global gravity Z is set to 0. Have a look at these. It's moving very slowly, just like it's on the moon. Let's set the gravity to 100 and see what happens. See, all these objects are going up because now our gravity is reversed. It's so easy. Let's do one thing. Let's set the gravity to -2. Now all our objects should fall slowly. You know, this object is falling down very slowly, just like it's on the moon. Yeah, so we defined what kind of gravity we use for this level. There are other settings as well. World to meter scale. If you move 1 unit inside Unreal Engine, what is that in actual world? So world to meter scale is 100 here. So that means if you move 1 unit inside Unreal Engine, that will mean that you are moving 100 units inside the real world. We'll go over all these settings in detail. You can check the documentation for more details on this. Let's go to project settings. When you go to project settings, this tab will appear and this defines settings for the complete project. So what is the description of the project? What is the thumbnail that we use? What are other settings for the project? How many maps are there? What is the default map? Default game map versus default editor map. Then packaging. There are packaging settings also for this project that you can define. What are the supported platforms that you want in this project? What is the target hardware? Then is there any asset manager? Is there an AI system, animation? All the global settings related to this project will be defined in project settings. Let me take you over one very important setting, which is input. If you play our level, you'll see that when I press ASWD, I'm able to move. Now, where is that ASWD defined? That ASWD is defined under project settings, under input. So if I just click on this plus icon under action mappings, you'll see that there is a new action mapping created. Now let's name it test action mapping. And let's bind it to any button. Let's press Y. So keyboard Y, when I press keyboard Y, this test action mapping will be called. Now, if you go to our character inside world settings, you'll see that our default pawn class is BP first person character. Now, if you click this browse button, you'll see we can double click and open up our BP first person blueprint. Inside first person blueprint, we have these hands, we have this camera, we have a collision component. And we just defined this test action mapping. So let's go to this blueprint and inside this blueprint, you should be able to access this test action mapping. Now let's print a statement on this. Print Y pressed because this is bound to Y. If I press play and press Y, you can see that the logs are appearing on the left side. It's saying Y pressed. This is how you define inputs, and you can access them inside your character. You can also access them inside your player controller. What is a character? What is a player controller? We'll go over that when we actually develop a game. For now, understand that this is how we create inputs and we can access them here inside the blueprints. Now, if you go to settings and you click plugins, this menu appears. Unreal Engine by default doesn't come with everything attached. A lot of the added functionalities inside Unreal Engine also come in the form of plugins. So if you go to this plugins menu, you'll see whatever plugins are there inside Unreal Engine. There are a lot of plugins that ship with Unreal Engine. There will be a lot of third-party plugins as well. Even you can create your own plugins. We'll have a small series on plugin creation as well. Let's just browse through a few plugins. So if you click on 2D, you'll see that Paper 2D adds tools and assets to help create 2D games. This is a plugin for supporting 2D games. For example, if you go to AI, there's an AI support plugin, a simple plugin that makes sure your project loads AI module and navigation system at runtime. Similarly, there are other AI plugins as well. There are plugins for Android, for animation, for audio, AR. See, there's Apple AR Kit, so Google AR Core, all these things, like whatever support you want to add to the engine, all these things come in the form of a plugin, and you can just tick this box and then it will ask you to restart the engine. Once you restart the engine, the plugin will be enabled. Now let's go back to settings and go to the scalability menu. Inside scalability, there would be an engine scalability setting. If you set that to cinematic, all our lighting computation, shadow computation, that would be like extremely high quality. If I set it to low, you'll see that there are no shadows and the particles look very blank. There's a trade-off between performance and quality. As you reduce the quality, the performance increases, and as you increase the quality, let's set it to high. Already this recording is hanging. Now if I set it to medium, the recording is smooth and also many details are preserved. So if you are running on a low spec PC, then it will make sense to run it on a low quality. If you have a very good PC, then it makes sense to run on high or epic. If you're creating a movie and you want a very cinematic quality, then set this to cinematic. So this is engine scalability settings. Similarly, you have material quality settings. You have preview rendering level. Preview rendering level, you can define like what kind of graphics API and the OS that you want to emulate, right? For example, I have selected here Android ES 3.1. You can select Android Vulkan. So as soon as you select Android ES 3.1, everything that is rendered, it will be in accordance to the Android 3.1 shaders. So see, there are a few lines here. This is how it will look on Android. So if you go back to our D3D shader model 6, which is the default selected for Unreal Engine 5, you'll see that these lines disappear. Since emulating Android, the rendering quality would be that way. So here also you'll see there's an Android icon. Let's go back and select D3D shader model 6. Yeah, the lines have disappeared and now the quality is also better. You can disable the Viewport UI. If I'm clicking this button, this View UI is disabled. So this was an overview of settings menu. Now let's go over all the settings that are present in this menu. So here you can show the FPS, you can show the statistics. In the bottom corner, there is also a console. You can enter any kind of console command. So Unreal has a huge list of console commands. Let's say I just type stat space FPS and you'll see that this FPS starts displaying here. If you go to Unreal's documentation and search for console commands, you'll find a huge list of console commands that Unreal has. You can use all these commands to switch on off different settings inside Unreal Engine. You can use this console for that. Inside any blueprint, you also have a execute console command option. If you want to run any console command inside a blueprint or inside any object, you can just type that command here and you can execute it. For example, we had earlier created this test action mapping and we had set it to Y. On pressing the button, let's execute stat FPS, and on releasing again, let's execute stat FPS. Now the FPS is shown. If I press Y, the FPS disappears. If I release it, it appears again. If I press it, it disappears. If I release it, it appears. So this is how you execute console commands from inside your blueprints. You can even switch on and off your FPS from here. There are many other stats that you can view inside Unreal Engine. For example, let's go to stat advanced and then go to collision. This will show all the collision related stats. For example, if I just full screen it, if I pick up a gun and shoot it, the call count that you see is 2 and all others are 1. If I shoot it, the call count will increase. See, This means that whenever I'm shooting a bullet, the engine is actually trying to compute the collision, and all the data related to collision queries is displayed in this statistics. Similarly, there are other stats as well. Like let's disable this collision and let's take a look at this emitter stat. There's a fire flame, there's a steam spark. So the debug data related to all the particle system can be viewed here. For now, frame rate stat is the most important stat that you can use to get started with. So you can keep on displaying this frame rate here. If you just increase the engine scalability settings, you'll see that the frame rate drops. If I set it to epic, right now my engine is running at like 100 or 90 FPS. If I set it at epic, you'll see it's reduced to 60-70 FPS. Now if I go back to medium, it's again running at 90. If I go to low, it's running more than 100 FPS. Let's set it to medium. You can view your scene from different directions. Right now we have a perspective camera that we can move around. If you want to change that to top view, you can see all the objects from the top view. Right now it is in wireframe mode. If I set that to lit mode, you can see all the scenes. This is useful in case you are creating a level or you are placing the objects. You can see exactly where each object is from a different point of view. If I view it from, let's say, left side, see, this is how it looks from the left side. Let's go back to perspective. Now our scene is in lit menu. Lit menu means that our lighting is on. If I set to unlit, you'll see all the lighting is off. So this is useful when you are trying to debug anything in the scene and you do not require lighting for that debugging. It's useful in that case. If I go to wireframe, this will show all the structures, all the 3D structures. You can see the sphere, you can see all the meshes that are there. Let's go to detailed lighting. See, this gives more focus on the lighting part. Now if you go to lighting only, then you'll see that it's like all our textures and all are missing. It's just the lights that are there. So this is useful in case you want to debug your scene with respect to lighting. Now similarly, you have reflections. See, all the complete reflection map is visible here. Then you have light complexity mode as well. So these are some of the optimization view modes. These will help you to find out where the bottlenecks in your scene are. So if I click on light complexity view mode, here you have a spectrum of colors, and based on the colors that you see on your screen, if you compare that with the spectrum that is visible at the bottom, you can actually find out what kind of lighting is extremely bad and what kind of lighting is good and what is decent. So all this lighting I think is a good lighting. All the lighting on the landscape seems good. The lighting in our scene inside our scene seems bad. If I just delete one of these lights, you'll see that the complexity will reduce. If I delete it, see, the complexity has reduced. If I delete this one as well, light complexity has become good because there are no lights in the scene except one light, which is the directional light now. Shader complexity is again one more thing. So how complex is the material or how complex is the coloring logic that you define in the materials? Here this is red. This is rendered in a more complex way, right? It's not a straightforward texture mapping. This is a slightly complex rendering. That's why you can see that all the particles are in the red zone. And if it's completely white, then it's bad. Green is good. So rest of the shading is good except the particles here. So if your scene is bottleneck, like let's say you added some new effect in your scene and now your scene is running very slow, then that time you can use this debug mode to debug the shaders. We can go in details over all these once we start understanding the engine in more detail. For now, you can understand these basic things and use them to debug your game. There's also one menu called show. In this menu, you can just click these things on and off. So let's say we do not want to see the landscape in our scene. Switch it off, there would be no landscape. If you do not want to see any kind of particles, let's say you want to debug your scene and you don't want to see our particles, just switch it off and see all the particles are disappearing. Similarly, if you don't want any static meshes, switch it off, no static meshes. You don't want any directional lights, switch it off, no directional lights, no point lights. This is useful specifically when you want to visualize a particular thing or you want to get that out of the scene temporarily. If you click use defaults, it will show everything. In the previous video, we had learned how we move these objects. When you drag any object, the movement is pretty smooth. But now let's say you want to snap it to a grid. So if you just enable this particular button, now this object will snap to a 10 unit difference. So if you go to the details pane and if you see the location, if you see the Y location, it's 2474. If I just drag it, you'll see that it will be 2484. It will be 2494. So this is how the snapping works. Let's say you want to snap to a 100 distance grid. So this is how it will snap. If you disable this, the movement would be smooth. Same thing is with rotation. Let's say you want to snap it to every 30-degree rotation. Now if you rotate, see, it rotates in a snappy way. If you disable this, it rotates in a smooth way. And the same thing is for scaling. If you use snapping for scaling, whatever you scale would be in a snappy way. If you disable it, whatever you scale will be smooth. There is one more menu, which is camera speed. So here right now I'm right clicking and using ASWD to move. Let's say you want to increase the camera speed to a lot. See, now my camera is moving faster. And now let's go to the play mode. So if you play this game, you can pause this simulation. You can even stop this simulation. So right now if I play, I'm able to move. If I press Shift and F1, I'll see the cursor. If I click this eject button, now in the playing simulation, I can move inside the level. My character is still here because I ejected. Now if I just click back on this button, I'll come back to my position. Now let's go outside. Let's press Shift F1. My cursor is back. Let's eject once more. Now your character is here. Let's say you're testing your game and there's something wrong with your character and you want to check how that character looks. You can just eject and see if there's anything wrong in the character while it's playing. Let's stop it. There are other ways to play also. So right now I'm playing and I'm directly possessing the character. What if I don't want to directly possess the character? You can go to this menu and press simulate. This is similar to ejecting. Basically our level will start simulating, all the physics will start simulating, but we won't be playing the game. This is specifically useful if you just want to simulate your level and see without possessing your character. There are other ways to play your level. So this is selected viewport. You can even preview it in a mobile. You can preview it in a new editor window. If I'm clicking this selected viewport, it starts directly here. If I click this new editor window, it will start in a new window. This is like the same thing, but in a new window. If you want to play it in a VR game, you can click this. If you want to play it as a standalone game, you can click this. Now we also see that there is spawn player at current camera location versus default player start. Right now it's selected to default player start. So if you check here, you have a controller, you have a flag, you have this icon. If you click on this icon, on the right side, you'll see it's a player start. So this object defines where your player will start playing the game. So if I play, I'm starting here. If I just move the player start here and play, you'll see that I'm starting from here. So you can change the starting location of your game using just this player start. And you can go to this basic menu and you can drag and drop a player start. So let's say your player start got deleted or your level doesn't have a player start. You can drag and drop a player start from here. Now if I play, my level will start from here. So if you go back to this menu, right now we have selected spawn player at player start. If we select spawn player at current camera location, so wherever your camera is, from there our game will start. For example, let's go on top of this hill. Now we have selected this to current camera location. Let's play. See, our game starts from here. Here at the top you have another menu, which is a blueprints menu. If you want to create a new blueprint, you can just click on this level, create a new blueprint. It will open the create blueprint menu. If you want to select a few objects and convert them to a blueprint, so let's say right now all these objects are separate static meshes. If I want to select all these objects and convert selection to blueprint class, so I can convert all these to stairs and I can click select. So you'll see that we have created a new blueprint using all these static meshes. So that can be directly done from here, convert selection to blueprint class. You can even go here and open any blueprint. You can search for that asset. You can also open the level blueprint. So you can write code for this particular level also. I wouldn't recommend using level blueprint because it is global to the level. It is usually better to keep the code separate into objects, into particular blueprint class, and not use the level blueprint altogether. You can use level blueprints if you want to execute any global settings or if you want to execute any kind of global changes to the level. Now let's talk about lighting in detail. So right now, if you check here, you have a directional light. I can rotate the directional light. I can rotate the directional light as I want. Let's look at a few properties of the directional light. You can set the location, rotation, scale. You can set if the light is static, stationary, or movable. Movable means that our directional light will change with time. If it is static, it means it won't change its location or direction with time. You can change the intensity of your directional light. You can change the color of your directional light. You can change the source angle. You can ask it to use temperature. So if it's using temperature, and see, you can set the temperature of the light. You can set if it affects the world, if it casts shadows. So if I disable cast shadows, you'll see all the shadows related to this directional light disappear. Now let's look at point lights. So similar to directional light, you can drag and drop point lights as we had already seen. You can change the intensity. You can change the color of those lights as well. You can change the source radius. See, you can change the source radius of the light also. Source radius will affect the size of the shadows, how the shadows look. So if you check this part, you'll see that it is changing with the source radius. See how it is changing. So how large is the light source? This is that property. So see, if the source radius is 0, our shadows are sharp. If the source radius is higher, we get soft shadows. If this light should use temperature also, then does this light cast shadows? All these are mostly common properties of the lights. Similar to point light. So point light affects in one particular area. This is the sphere in which it affects all the objects. Similarly, there is a directional light. Directional light will affect almost all the objects and it will be at an infinite distance. You can set the location of the point light. But if you change the location of the directional light, you'll see nothing happens. Because directional light is like sun. It is essentially at an infinite distance. Now you can also place a spotlight. Let's say you want a spotlight. You can increase the intensity of your spotlight. You can also place a rectangular light. These are just different types of light with different shapes. You can also place a skylight. So if I delete the skylight, see, there is no light because of the sky. This area is completely dark. This kind of thing doesn't happen in real world. In real world, there will always be some kind of light. So if I just drag and drop the skylight, you'll see that this is not completely dark, but there is some light. This is more like an ambient light. Now let's say if you want to create a new level, you want to create some scene, you do not have the static meshes for that level ready. Basically the 3D art team is working separately on the level, on the static meshes of the level, but you still want to start the level designing process. So we need some kind of temporary actors that you can place in the level. So if you go to this geometry tab and drag and drop any object, a box or a cone or a cylinder or a sphere, these can act as a basic building blocks for your level. So this is called boxing your level or white boxing your level. You can just go to the brush editing setting here. If you enable the brush editing mode, then you will see that these shapes change their color. If it's in a selection mode, then they'll have different color. If it's in editing mode, they'll have a different color. Now when it's in editing mode, you can select each face and you can drag that face forward and backward. Why are these boxes required? Why cannot I directly use the cube and just scale this cube? Why do I need this box? So to explain that, let me just try to apply a material here. So for example, let's take this grass material. Let's apply this grass material on this face. Also, let's apply this grass material to this cube. See the difference between this mesh and this mesh. So when you scaled this mesh, the UVs for this particular mesh are still the same, but this one, the mesh itself increased. The UVs are getting adjusted properly because you are not scaling the mesh. So if I go back to selection mode and now if I scale this, if I scale this object, then the mesh will get distorted because I'm scaling the mesh. Here I'm not scaling the mesh, but actually increasing the mesh surface itself, which means that the geometry that will be extended here, it won't stretch the UVs of the mesh. So let's go to brush editing mode and If you check this side, see, this doesn't increase or stretch the UVs. That is why we use the geometry tab, because it's an inbuilt geometry inside Unreal Engine which you can change and modify on the fly. Let's talk about Quixel Bridge. So recently Unreal Engine or the Epic Games team bought a company called Quixel. Quixel goes around the world and does high quality 3D scans of the real world. All the real world assets are present inside the library of Quixel. Now Unreal acquired this company called Quixel and integrated all their assets inside Unreal Engine. If you right click on your content and you click on this add Quixel content, then Quixel Bridge will appear. Quixel Bridge is the asset library of Quixel. From here you can download all the realistic kind of assets. So let's select this neoclassical modular building. Here see, there are a lot of modular parts using which you can actually build your buildings. So there are things like city street. So in city streets, what are the things that are there in city streets? There are some road blockers, there are some broken pieces, there are some stones. The pavement, the roads, all these structures have some materials, right? All those materials are present here. You can take up all these materials, you can take up all these assets, and you can actually create a city street from there. For example, take a look at this kind of butcher house. If you go to natural, see, there is a broadleaf forest. Now let's go to broadleaf forest. See, you'll have all kinds of trees here. Let's go to vegetation. And let's go to crops. So let's say we want to add crops in our level. Select this, select all these 3 or 4, and I think you'll have to sign in using Epic Games. So once you select all these assets and once you sign in, you can download and bring these assets inside your project. So let's just press download. So the download for these assets will start. So I think the plans are downloaded. If you go to content and then mega scans, you'll see that there's a 3D plans and there's a folder related to that. Yeah, all the plans that we downloaded from Quixel Bridge are here. Now let's talk about the Foliage Tool. Inside any game, there would be a lot of trees, there would be a lot of stones, all the meshes that are placed in a huge number, grass or trees or stones, all these kind of things. There is a particular system inside Unreal Engine known as Foliage system that specifically handles these kind of meshes. If you select this Foliage tool, on the left side, you'll see drop foliage here. So you can select all kinds of vegetation. For example, let's just select this one and this one. Let's select these two. And let's drop them into foliages. It will convert those assets to foliage type and save it. See, now once you select these assets, you can actually hover over these assets and you can see that there is a blue tick on the top of these assets. This means that now when I start drawing, these foliages will appear. So let's do one thing. Let's reduce the brush size a bit and let's just click and start drawing. Or let's cover this whole mountain with flowers. This one, we have a very good mountain here, or hill. Let's cover this whole hill with flowers. See. So see, my complete hill is covered with foliages. In this way, I can actually add different foliages. I can even remove them. So I have a paint tool here. Instead of that, if I select erase tool, that will start clearing out these foliages. See. Now these extra foliages I can just get rid of. Now let's take a look at the Unreal Marketplace. Now if you go to the Epic Games launcher, if you go to the Marketplace tab, you'll find all sorts of assets here. Whatever things you require for game development, people are actually creating those things, selling that to you. So let's take a look at one asset pack here. See, this is the vegetation 2 pack. These kind of beautiful assets are all available on Epic Games. So these kind of levels, these kind of characters, animations, UI system, sound system, basically all the things that you require for your game are available on Epic Games Marketplace. Similarly, there are a lot of free assets also. If you go to free and permanently free collection, Epic Games gives you a huge list of assets. Check out some of the assets which are like amazing. See here, there is gallery and showcase. See, this complete gallery level is free. You can create a virtual gallery, virtual art gallery. For your VR virtual art gallery, you can just pick up this asset pack. It's free. See, all these vehicles are available for free on Unreal Engine Marketplace. So these are just some of the assets. You'll find a huge list of assets here which is free. There are also marketplace collections, which is again another list of free assets that you have. Then Unreal also gives you a lot of assets which are free for the month. So for a particular month, all these assets would be free. So I haven't added those, but let's just quickly add them to our cart. And I forgot to add the free assets for this month in my asset library, so I'm doing that right now. Inside Epic Games Launcher, there's also a samples tab. If you go to this samples tab, you'll find a lot of sample assets, sample content packs here. There's a starter game, which you can use to refer for your shooter game. There's a city sample, there's a meta-human sample, MLD formation sample, hillside sample, car configurator, Meerkat demo, DMX previous sample, Virtual Studio. There are a lot of games. See, there is a multiplayer game, there's an inventory sample, there's a stick game, 2D game, there's architecture visualization. So all the things which Unreal is capable of, you have a lot of samples free inside Unreal Engine which you can use to learn. You can just click on any project and you can just add it. You can just start downloading it and start using it in your project. It's free of cost. You can take benefit of these samples available as well as the free content assets. Just sit down a day, download a sample projects and explore how it is working. I'll also be coming up with a series in which we take up a sample project and we break it down so that you guys understand it clearly. There's also another tab inside Unreal Engine called News tab. So if you go to this News tab, you'll find things like what is the latest version of an Unreal Engine. You'll find the forum, you'll find the roadmap, Q&A. You'll find a lot of coverages of studios and teams that are trying to use Unreal for producing any kind of 3D visual experience. You'll find blogs here. There is also an active Discord community called Unreal Slackers. You can just add yourself to this Unreal Slackers Discord server so that you get all the updates. You can even post your queries. You can see what other people are doing. There are even job openings, like there are freelance jobs coming up on Unreal's Discord. Basically, most of the active online discussions around Unreal Engine go on inside the Discord. So see, people will post their doubts regarding graphics. People will post their questions regarding lighting, level design. So on whatever part of Unreal Engine you are working, you will find questions. You will find answers to questions here. People will help you out. So that way Unreal has a very good community of developers who help each other in creating different things. See, there are people who are creating things now right now. So this guy has created this ocean, which looks good. I hope you have slowly started to understand how Unreal Engine works. In the upcoming videos, we'll be creating a few simple game mechanics using blueprints so that you guys understand how powerful and easy it is to create things in Unreal Engine. Till then, have a nice day, take care, bye bye.